Hello everyone, welcome to Code with Raj. So today we would be solving our next question from our top interview 150 series, which is best time to buy and sell stock part 2. So you need to watch the previous part before attempting this question. I would recommend because this plays a very different concept from the previous one. So let us read what this question says. You are given an integer array prices where prices I is the price of given stock on ith day. On each day, you may decide to buy or sell stock. You can only hold at most one share of the stock at any time. However, you can sell and buy multiple stocks on the same day, ensuring you never hold more one share of stock. Find the maximum profit you can achieve. Okay, so let us understand using the first example. What is this question saying? Yeah. So the first example is 715364. So like you need to understand that earlier what we were doing is we need to buy at only one particular point and sell at one particular point. So we were just caring about the minimum value before the point we buy. But here we can buy n number of times. Like in this case, the optimal way would be to buy at 1, sell at 5, buy at 3, sell at 6. Net profit would be 4 plus 3, 7. So here like we need to try and buy in such a case such that we achieve the net profit as maximum. So like one thing you can see here that we need to try all possible combination in order to check whether we will get maximum profit or not. If in this we try any type of a greedy method, we will fail because suppose here you think about trying greedy, you buy at 1, then you think that where to sell. Let's see, you got 5. Let us find something bigger. After that, you find like 6. So you will sell at 6. So 1 minus 6 would be 5. Then you cannot buy afterwards. So our profit will be less if we try our greedy method only. So we need to try all possible combinations. Combination like we need to try that each point can be a selling point, can be a buying point, or can be a skip. Because you can see we like we didn't buy at 7, we didn't buy at 7, we buy at 1, we sell at 5, we buy at 3, we sell at 6, and nothing for 4. So these two are skipped and only these 4 are used. So like we are having 3 cases. Either we could sell on a particular day, either we could buy, and we could skip. So let us read these conditions individually once. Sell, buy, skip. So for skipping, I don't think so there is any specific requirement. We could just skip the index and move on further. But if you want to buy, you must have sold the stock previously, or you are not holding any stock, then only you can buy. If like you have already bought one, then you cannot buy 3 again. You have to sell this one, then only you can buy the third stock, like the stock with the value 3. So this is the condition that we need to keep in mind, that if we have bought the stock earlier, we cannot buy again. So we have to keep this in mind. And for selling, you have to buy a stock at least. Like you cannot sell if you haven't bought a stock. So this is the primary condition that we would be working on. So like since you guys got a hint, like since this question is asking us to explore all the possible cases, and in all the possible cases we need to output the optimal one, which is the maximum possible profit. So this gives us a hint of a recursion, because in recursion we can explore all the possible cases and try to find the optimal one. Okay, so first we'll try to write the recursion code, then we will see that how can we optimize it, or what can be done. Okay, so let us start again. uh, uh, hmm. So we were having so imagine, so for recursion what basically we do is we first think of the base case. Like what if the array size is only 1, suppose it has only 7. So what we will do, like either we could skip. So if we skip, let us have a variable which will store our maximum profit equals to 0, because we haven't started anything. So profit equals to 0 and we are starting now. So if we supposed to buy at 7, okay, so we bought at 7, and let's do a very simple calculation. If you have like stock at price 3 and a stock at 5, price 5, so if you buy at 3, so your profit will be minus 3. Then if you sold at 6, your profit would be minus 3 plus 5, 2. So this is a very simple maths. I guess everyone would get it, that what I'm trying to say is if you buy, your profit reduces to negative of that value, and if you sell, you add the number to your profit to get your answer. We will be using this concept to store the profit dynamically for every buy and sell operation. So if you buy, your profit becomes minus 7, and at last, since nothing is there, so you cannot sell. So this is a bad case. So if so if you're so we move on to like next element after that. So we cannot sell, and if you try, you cannot sell either because you haven't bought. We could only skip, so our skip will give us maximum profit, which is 0. So our base case would be like this: if we are reaching the end, like we don't have any element. So if our value is at end, suppose if I have an index through which I am traversing, if this becomes to the size of the array, we cannot have any profit, so we need to return 0 only. This would be our base case which we would be working on. Okay, I hope you understand what I'm trying to say. So let us take this only 7 1 5 3 6 4. So we will be starting from our first index, and each will have 3 options, and we will have a pointer or you say a variable which will store whether the stock is bought or not, because we don't know at further because we need to know that if we had already bought previously or we have sold previously, then only we can perform buy and sell operation, because they are interdependent on our past actions. But skip operation is not interdependent on a past action. So in skip operation, we would just we would not update this variable. So first of all, we have 3 cases. 7, at 7 we could buy, we could sell, we could skip. So if we decide to buy, then our variable we initialize it to 0. If it is 0, that means we haven't bought anything. If it is 1, that means we are holding a stock. So we will change it to 1, and for this it will pass on to the next index 7 1 5 3 6 4, and the pointer will point here, and here let's make the value 0, and here it will become 1. So our current profit is -7. Then again we will move further. Like what we can do at this point, we could either sell, but we could either sell, or we could either skip, or we could buy. Can we buy? No, because we already have bought a stock and a variable is 1. So we have only 2 options, to either sell or skip. So if we sell, our profit would be like -6. -6 profit would be stored here, plus the profit that will come after the further call. So -6 and 7 1 5 3 6 4. Our pointer will point to 5. Okay, so next call what we can have from 5, either we can buy or we can skip. Yeah, we didn't wrote the skip part. So if we skip at this part, our profit will remain as -7, and 7 1 5 3 6 4, we would reach on to 5. So at this point, if we skip, we can again do 2 operations only, which is either we sell it or we skip it. So like I'm saying that using this tree, this recursion will explore all the values, and at last, suppose it reaches the end, then it would return 0 because it has reached the nth index. Suppose this reaches the nth index, so it would return 0, and we'll keep on adding the profits. So if the profit was suppose -6 here, we got a 4 here as we sold. So 0 plus 4 plus -6. So through this particular branch, we got a particular set of profit, and since we want to maximize it for all the branches, we would take the maximum of it. Like I hope like you are getting what I'm trying to say. So let us write the recursion code and like think like what you can do. Think like how can we optimize it further. So let us have a function int f which will tell us our maximum profit. It will be holding the index and a boolean value bs, which will tell whether the stock is bought or not. 0, if we haven't bought anything, we will store it as 0. If we have bought, we will store it as 1. Buy, sell, and the vector int and prices. Okay, so let us first write our base case, which was if index equals to prices dot size, we would just return 0. Okay, next what we could think of is first case, buy. So int buy. So first we need to check whether we could buy or not. So currently we will store it as 0, and if bs equals to 0, then only we could buy. So we could think of a buying situation. Let us write the same for sell also. So I would just copy it and paste it, and instead of buy we would write sell, and instead of bs equals to 0 we'll write 1, because at that point we could sell. And here create a new comment, sell, and at last we would have a skip. So skip was very simple. We don't need to do anything, just pass. So if we are skipping, so int skip, what will the skip do? We will just move on to the next index, like recursion would handle internally that what would happen later. So f of index plus 1, and we wouldn't change the BS value and pass the prices as it is. And for buy case, now the main comes part. So the math I told you earlier, like if we are buying a stock, basically we are reducing that amount of money from our profit. So buy would be minus of ARR index, because we are subtracting that amount of profit, plus f of index plus 1, and we would change the value of BS, because if we have bought, it would become 1, and prices. And then if BS equals to 1, we could change our cell would be ARR index plus, because we would add the amount to our profit if we are selling. Index plus 1 comma 0 comma prices. Here why we are giving 0, because we have sold the stock, we are not holding any value, so we could sell. And at last we would just return the maximum value of all these. So maximum of skip comma maximum of buy and sell. So basically this will go to all the branches of the recursion, and we'll find out that at which point it is becoming maximum. So like idea of recursion is you don't need to dry run or everything, because it would take a lot of time. The best approach which I follow for doing the recursion is I think for the base case and what could be the possibilities, and I let the recursion handle the rest of things itself, because we know that if we are trying to buy this particular index, we would take this and we would call a recursion to see and fetch like whatever could be the maximum at the endpoint. Similarly here and here also. So I think this should work now. So yeah, one thing we need to return is from the main function, we need to call return f of, we are starting from index 0 and currently we don't hold anything, so again 0 and prices. We are passing prices in a reference value so that the operation become fast. So let us try to run this. Okay, so it is prices, not ARR. Let us correct that. I guess it should work now. Yeah, so you can see this got accepted. But now what is the problem? Since we are dealing with recursion, what will be the time complexity? So you can see there are 3 branches in this recursion. So our expected time complexity will be power of 3 comma n, like n is the size of the array. So but here n is given to be, oh sorry, not 3 power n, yeah, 3 power n only. Exponential, basically I want to say that the time complexity would be exponential only, but the n is given here to be around 10 power 4. 10 power 4, so it would give a TLE. So let us try to submit this and see that whether we are getting a TLE or not. So we got a time limit exceeded at the 198 test case. So like one thing what we can do is, now we need to optimize. So like think of this thing, like there is a very amazing pattern that you would see, that we need to try and memorize this solution, because there would be many cases. For example, 3, 6, 4, 5, some arrays like this, and this call like there can be 2 cases here, no? Like to sell, suppose we have bought earlier, to sell or skip. So this goes here 3, 6, 4, 5, 6, and this comes to here. Okay, and if we suppose if we sell, yeah, and if we skip also 3, 6, 4, 5, 6. Now we could sell at this point also, and we could sell, we could buy and skip at this point also, and here we could sell and skip. So you can see like this problem would have been solved in some of the other branches, but we are trying to compute this again. Imagine if this was already, we already had stored answer of this at some position. We could just return that answer and use it, like going deeper into this branch. So we could reduce this exponential time complexity to big of n. Why big of n? Because we won't be trying all the 3 possible cases. Instead, the sub problems which have been solved, we would be using them. We would be storing the value at some particular place, and if we see that that value has already been solved, then why to push a recursion again and like get the value? So what we would do is we would store that value somewhere so that we can use it. I will show you in the code that how we would be doing that. Okay, so like let me tell you the simplest way of memorization that we could do. We won't use like there are two ways. Either you could use a vector or you could use any data structure which stored. So here we would be using our map pair int comma int mp. So now you need to see one thing. Why pair? Because for the recursion we are using an index value and a boolean value. So we need to have two values on. Basically, if we call this function, it would return anything. So this function is containing two parameters, and for every value that it will return, we would be storing that after the base case. So if we found np.count, if we found that this pair already exists in our data structure, why to compute again? We would just return that. And we this for the returning if you already found, and this one for saving the value, because this return will return the function value at every point. So we need to store it in order to check whether we are having it or not. So mp of index comma vs. Basically what this is telling is if we are only having array till this index and at last position we have decided to buy, what would be the maximum profit that we would be able to make? So let us try to run this now once. Return, I guess there is some issue with the formatting. Yeah, so I need to put one more bracket here. So this got accepted. So now we will try to submit it and see that now what is the problem if we are using this type of data structure or something like that. So see, this solution got accepted, but like we are using too much memory. Like if we consider the memory that we have used, you can see that we are using too much of memory here. So like this is not a very good solution. Like you can basically you can use this problem. You can use this solution in an interview. Like this would be giving us the best time complexity, but won't be giving us the space complexity, because for storing the map we are already using extra space. So we go of n for the map, but we are also utilizing the extra recursion stack space, because suppose there are n number of calls, so n number of calls would be placed in the compiler stack space, so that would be also used up. So what else we could do? So from memoization we should move on to tabulation, basically using for loops instead of doing this all calculation. So like you can see there are many videos on YouTube for doing that, but I would tell you a simple trick that if you have written recursion somehow, I will tell you the easiest trick to convert this recursion into a memoization. Just very simple trick. So you can see that like where from first we need to initialize our DP table. So vector int DP and comma. This is how you initialize a 2D array in C++. N plus 1 comma 0. Why n plus 1? Because we are going till prices dot size, which is n. So if we want to access the index n, the size should be n plus 1. And why 0? Because our base case we have 0. We are setting the value 0. So if we have taken it anything else, we need to initialize the base case separately. So to avoid doing that, I am just simply taking initially the where DP initialized to be 0 for making the thing simple. Now what we need to do? So our index, so how is our index moving? So basically our index is going from like in recursion you can see that we are always calling the value of index plus 1. Okay, so we need the future value in order to compute what is at present. So this gives you a hint that our first, so how would be computing this? We are calculating all the possibilities of index and BS. So if assume, let's do a basic maths, a basic PNC. There are n ways of happening of event 1 and there are m ways of happening of event 2. So what are the total number of ways if both events can happen simultaneously? N into m, obviously. So if this index vector is going till n and this boolean vector is having a value 0 or 1, so first we will iterate for n, and inside this for loop we will be having 0 or 1, or vice versa. You can have 0 and 1 outside and from 1 to n inside. You can have both of these things, but like to have, and because n into m will store all the possibilities and we need to explore all the possibilities that are possible, so we will be running two for loops to compute all the possibilities. So let us write that in the code. Yeah, so computing both the possibilities, we would have for int I is equals to n minus 1, I greater than equal to 0, I minus minus. So why I have done I is equal to n minus 1? Because see that at this point we need to call the value which is further to it. So while filling the DP table, we are filling it from the back. Like we are checking, we are starting from the back in this tabulation format, because in the recursion, our recursion was going till the end, till n, to find out the final answer. So we need to start from n only, because we will keep computing the answer below. And we have initialized this with 0. So for int I is equals to 0, I less than 2, I plus plus. So it will run for only 0 and 1. And now simply we would paste this simply, like we would simply paste this. We would copy this till here. Since we have done the base case, we don't need to copy that, and we would come and paste this here. Let's format a little bit. So you can see now inside the loop we got our buy, sell and skip. Just the thing we need to do is that instead of returning this, we would write dp of I comma j, or to make the thing more even more simpler, since we are using the term index and bs, so index and bs, and we will name our loop also like that. Instead of I, we would be using index. Okay, yeah. So yes, you can see if buy is equals to 0 or bs equals to 1, we would do the following, and instead of calling f, we would write a dp dp, and let us remove these brackets. Dp of index plus 1, yeah. So this is the very simple way from which you can convert any recursion to dp. So we converted this. Now what we need to do is just we need to return c. So we were returning f of 0 comma 0, so instead of returning f of 0 comma 0, we would return dp of 0 comma 0, because our dp is initially a function only, that recursion function, just we have stored it in a data structure. And let us write int n is equals to prices dot 6. Yeah, converting skip also, dp of index plus 1 base. Okay, so we do not need this function now, so let us comment this function and map also. And now let us try to run this once. If, yeah, so you can see this got accepted very well. And the thing which I wanted to tell you is like, be cautious while using uh, this conversion table, because the trick which I told you, you need to be very careful while making the loop statements, because sometimes what the students do is they reverse these loop statements and get wrong answer. So this is a very easy trick, but implement it very carefully. So let us now submit and see. Okay, memory limit exceeded. I guess there is one thing. Okay, so now why is the memory limit getting exceeded? So since we are using this 2D vector uh, uh, two times, one thing I did wrong, because what I did wrong was basically this was only 2 comma 0, because the like the second vector which you would be using is only having the two, is only having two space, but I wrote it for n, hence I got a memory limit exceeded. So like, yeah, let's run it again, and I guess we should get a correct answer now. So you can see our solution got accepted. Don't care about this. So now what will be our time complexity? So our time complexity remains the same since we are doing everything in one pass. So big O of n is our time complexity, and the space complexity only big O of 2n, because we are having two, like basically two vectors aligned with each other, the 0th one and the 1th one with containing n indexes. So big O of 2 times of n. So this is the most optimal solution that you could think of. I would like to give you a homework. Try doing space optimization. Like, instead of like using big of 2 into n, try to use a constant space. This would be your homework. Like, basically you can see there's a pattern. We are always using dp of 1. Basically what you could do is you could store the value of this dp of 1 in some other vector and like increase it. Try to search this and try to do this in the homework. That's all from my side. Thank you for watching the video. I hope you understand the solution. We applied all the three approaches in this question, and this is a very important question since many of you struggle with DP. So this was a very easy trick to convert recursion into DP. Just you need to perform the recursion very well and have to be strong in the recursion. Thank you so much for watching. Please make sure to like and comment, like, subscribe, and leave your feedbacks in the comment. I would love to hear your feedbacks, and the code link would be available in the description soon. Thank you so much for watching. Bye.